Tonight, you look at the sky, and something feels wrong. One star is brighter than anything you've ever seen. It wasn't there yesterday. It shines brighter than Venus, brighter than any planet, bright enough to cast faint shadows on the ground. Astronomers around the world are awake. Observatories are pointed at the same place. News channels interrupt their programming because that star isn't being born, it's dying. And what we're seeing is the beginning of a supernova. A supernova happens when a massive star reaches the end of its life. For millions of years, gravity tries to crush it inward, while nuclear fusion pushes outward. But eventually, the star runs out of fuel. Fusion stops. Gravity wins. In less than a second, the core collapses. Temperatures rise to billions of degrees. The star rebounds in a titanic explosion that releases more energy in a few moments than our sun will produce in its entire 10 billion year lifetime. For most supernovas in our galaxy, this would just be a spectacular light show. But this one is different. It's close. Distance is everything. If a supernova happens 1,000 light years away, we'd just see an incredibly bright star in the sky. Beautiful. Harmless. At 100 light years, things start to change. Earth would be exposed to intense radiation. Our atmosphere could begin to suffer damage. But inside about 30 light years, scientists believe the consequences could be catastrophic. So what actually happens if a star explodes near Earth? The first effects wouldn't be fire or shock waves. Space is too empty for that. Instead, the danger arrives invisibly. Radiation. Within days, a flood of high-energy particles and X-rays reaches our planet. Satellites begin to malfunction. Some shut down completely. Communication systems become unstable. GPS signals drift. Space agencies scramble to put spacecraft into safe modes. From space, Earth is being hit by a storm we can't see. Then, the sky changes. The supernova becomes so bright that it's visible even during the day. At night, the darkness never fully returns. Shadows appear under the stars. People gather outside to film it. Social media fills with videos of a second sun. But the real damage is happening above our heads. The radiation begins breaking apart molecules in the upper atmosphere. One of the biggest casualties is the ozone layer, the thin shield that protects life from the sun's ultraviolet radiation. As ozone levels drop, more UV light reaches the surface. Plants begin to suffer. Crop yields fall. Phytoplankton in the oceans, the base of the marine food chain, start dying off. Sunburn becomes severe in minutes. Skin cancer rates would eventually skyrocket. Ecosystems around the planet begin to feel the stress. And that's without considering one of the most dangerous possibilities, a gamma ray burst. Some supernovas release narrow beams of extremely high energy radiation. If Earth were in the direct path of one of these beams, the damage could be far worse, potentially stripping away large portions of the ozone layer in a short time. Some scientists even suspect that past mass extinctions on Earth may have been linked to nearby cosmic explosions. It sounds terrifying. And it is. But here's the important part. Right now, there is no known star close enough to Earth that poses this kind of threat. Famous stars like Betelgeuse, even if they explode, are far too distant to cause serious harm. The universe is violent, but space is enormous. Still, events like this remind us of something humbling. We live on a small world, protected by layers of atmosphere, magnetic fields, and distance. Most of the time, the night sky feels calm and eternal. But every point of light up there is a star with a life story. And somewhere in our galaxy, at this very moment, a star is reaching the end of its life. One day somewhere, one will explode. And when it does, the universe won't ask if we're ready.